Okay. So we're going to talk about network automation, which is all the new fun stuff that Cisco has come up with to make our lives way easier. Yay, right? We like easy. We like automation. Um, it's an important part of our jobs. And there's a number of different ways that we can go about this. So there's different objectives to this. First, we're going to talk about some of the data formats, like JSON and XML, and then we'll talk about APIs and how APIs allow us to facilitate interaction between two applications. We'll talk about REST APIs is what we're using specifically for our networking applications. Some of our configuration management tools that are available, and the vast majority of those are dealt with through REST-conf, which would be the protocol that we'd be using. And then we have we're going to talk about IBN and Cisco DNA Center. So IBN is intent-based networking, which allows us to automate our network and facilitate the allocation of our resources in a way that best suits our business model, depending upon what that model might be. And of course, that's going to depend on what business you have. So some of the benefits of automation, machines can work 24 hours a day without breaks, right? And that results in greater output. Machines also provide a more uniform product. Automation is going to allow a collection of lots of amounts of data that can be quickly analyzed to provide information which can help guide an event or process. Robots are used in dangerous conditions like mining and firefighting and cleaning up industrial accidents, so it reduces human risk. And under certain circumstances, smart devices can alter their behavior to reduce energy usage, right? Or to make a medical diagnostic, or even to provide, automobile safe driving. So there's lots of, this is an exciting, almost scary time when we have more things controlled by machine intervention and not so much human. Granted, as they're learning, there will be errors. So as we're programming these devices, there will be errors, but it's still the amount of errors through automation versus through human error is substantially different. People make way more mistakes. So, and kind of when you think about like the automation process for self-driving cars, right? There have been some mistakes. Of course, there were some mistakes, and anytime that there's a mistake, it gets reprogrammed and gets integrated. The number of mistakes with Tesla automation versus the number of mistakes from people just driving, being stupid people, texting or whatever, it's substantially higher for people to make those mistakes than it is for machines. So yeah, like I said, this is a scary and interesting time that we're in right now. So thinking devices, I hate that term, thinking, and AI. So most devices do have some sort of smart technology built in. When a device takes a course of action based on data input from an outside source of information, that data is considered a smart, that device is considered a smart device. So basically it's taking information output from something else and inputting it into that and then making some configuration changes. There's lots of devices that we interact with now that have the word smart in their names. And that indicates that the device has an ability to alter its behavior based on its environment. In order for devices to think, of course, they have to be programmed using network automation tools. So in the case of network automation, thinking would include coding software triggers for load balancing, for example, right? Which is wonderful because that way our phone isn't ringing. We've already set up a trigger through programming that will fix any issues like that. So all of these things are going to have different data formats. And when we think about data formats, we're really talking about the structure of the languages. There's a video on XML, HTML, JSON, and YAML, and sort of comparing the different data formats. So JSON, XML, and YAML are going to be the main languages that we used for networking automation. And the data formats are just a way of storing and exchanging the data in a structured format. So for example, hypertext markup language, or HTML, is a standard markup language for describing the structure of web pages, right? And we've got opening tags and closing tags. And so the data format that's selected is going to depend upon the application, the tool, or the script that you're using. Many systems will be able to support more than one data format, which allows us to use our preferred one. So if JSON or Python is our preferred format, we can use that. So our rules, data formats have rules and structure that's similar to programming and written languages. And each data format will have specific characteristics, syntax, how objects are represented, and key and value pairs. So that's how we're going to identify and represent our data. And when we're comparing the different data formats, as you can see here, our key is message, and success is the value, timestamp. So we're comparing JSON and YAML and XML. With JSON, we've got quotations and colons. With YAML, we just have white space and colons. And of course, with XML, we've got opening and closing tags. So we're just comparing the different data structure formats, and we're showing the exact same data structured using 3 different formats. JSON is a human readable data format, and it's used by applications for storing, transferring, and reading data. It's a real popular format used by web services and APIs to provide public data. And that's because it's easy to parse, and it's also can be used with most modern programming languages like Python. And some of the syntax rules, basically we have a hierarchical structure, and we have nested values. It uses curly braces to hold objects and square brackets to hold arrays. And its data is written as key value pairs. And we don't have to worry about white space. It's not significant. Whereas in YAML, white space is significant. And I hate fighting with white space, honestly. But in YAML, the hierarchical structure is shown just by white space. Let's see, more syntax rules. So when a key contains more than one value, of course, it's going to be considered an array. An array in JSON is an ordered list of values. And each value in the array is going to be separated by commas. So for example, here's a list of IPv4 addresses and what that might look like. So the key is addresses, and each item in the list is a separate object separated by curly braces. And the objects are 2 key value pairs. So an IP address, IP is, and subnet mask, those are both keys, and they're separated by a comma. The array of objects in the list is also separated by a comma, following the closing brace for each object. So you can see how, just by looking at this structure, you can see how it could be much easier to manage programming your network using these types of arrays, especially if you have a really large network, or especially if you have something that you're replicating, right? So our YAML data format. YAML is another type of human readable data format, and it's used by applications for storing, transferring, and reading data. And some YAML characteristics, so it's like JSON, and it's considered a superset of JSON. It has minimalist formatting, so it makes it easy to read and write. And it uses indentation to define its structure without the use of brackets or commas. So white space is extremely important. With XML data format, it's kind of outdated, but it's another type of human readable data format, and it's used to store, transfer, and read data by applications. It's like HTML, where there's a standardized markup language for creating web pages and web applications, right? It's self-descriptive, so it encloses data within a related set of tags, a tag, the data, and then the closing tag. And unlike HTML, XML uses no predefined tags or document structure. So XML objects are one or more key value pairs with a beginning tag used as the name of the key, and then the value in between the opening and closing keys. So we'll have tags. And APIs. APIs are your friend, and there's so many out there. And there's a great video talking about APIs, and it explains, SOAP and how SOAP is, old Microsoft interacting with HTML web pages, REST, NetConf and RESTConf for networking, and how to execute an API call in your browser and using something similar like an application like Postman. And Postman is a free application, so you can certainly download and install that and play with some of these things yourself. An API is software that allows one application to access the data or services of another application. So it's a set of rules describing how one application can interact with another and the instructions to allow that interaction to occur. The user sends an API request to the server asking for specific information, and then receives an API response in return from the server along with the requested information. And they use we use, a waiter is probably a good way of thinking about the API concept. So we've got a customer and we're using the API as the waiter, as an intermediary between the kitchen and the food and us, right? So it's an intermediary. Another really good example that they give is airlines, right? So to really understand how APIs can be used to provide data and services, we can look at a couple of different options here for airlines. So for example, we've got, I want to book a flight, and I want to book a flight from here to New York. And in doing that, I can either go to the airline's website and enter my information and get just their information, right? So the website's going to interact directly with the airline's own database and then provide the user the information requesting, matching the user's request. Or I could use a travel site, and a travel site basically using APIs would take my input, which is my requirements for flight, and get that information from all of the different airlines and give it to me. And I don't want to use any specific company names, but we all know all of the different travel sites that are available out there. So it acts as a messenger between the requesting application and the application on the server, and it provides the data or service. The message from the requesting application to the server where the server resides is known as the API call. So we've got different kinds of APIs. We've got open APIs or public APIs, and those are publicly available and can be used with no restrictions. Because these APIs are public, many API providers require the user to get a free key or token prior to using the API, and that's so that they can control the number of API requests that they receive and process. and Google has a huge list of APIs that are available. Internal or private APIs are used by an organization or a company to access data and services for internal use only. An example might be an internal API allowing authorized salespeople to access internal sales data on their mobile devices. And then we have partner APIs, and those are the APIs used between a company and its business partners or contractors, and that facilitates the business between the two of them. A business partner may have a license in one form or another, or some sort of permission to use the API. A travel service using an airline's API is an example of a partner API. And we've got a number of different web service APIs. A web service is a service, of course, that's available over the internet using the World Wide Web. And here are some of the web service APIs. We've got SOAP, REST, XML, RPC, and JSON RPC. And as you can see, SOAP was first released in '98. REST also has been around for quite some time, as well as XML. So REST. There's a good video on REST and showing you how to execute a REST API. You can do it either from your web browser or from the command line. And when you look at the video, they're showing the REST API using curl from the command line. You can also use that through PowerShell, which is pretty cool. And you get a little bit more raw data when you do it from PowerShell. The REST API is an API that works on top of the HTTP protocol, and it basically defines a set of functions that developers can use to perform requests and receive responses using the HTTP protocol. The standards like get and post and put and delete. And so it's conforming to the constraints of the REST architecture. When something is conforming to those constraints, it's considered RESTful. Excuse me. So REST and RESTful APIs. REST, some of the main things that you need to remember is that REST is stateless, it's cacheable, and it's a client-server model. So an API is considered RESTful if it meets that criteria. For our implementation, it's using common HTTP methods like post and get and put and patch and delete. And so this table kind of shows how it corresponds to the RESTful operations of create, read, update, and delete, or CRUD. So all of these acronyms and all of these different implementations, you need to be familiar with all of these and how they're used, simply because that is the way our modern developers are working things. And so if you're looking for a job, you need to be familiar with how through programming we can manage all of these things, which is so much better than sitting, at the command line interface through the Cisco iOS on each individual device. So we know what a URL is, right? Well, the URN is the resource without the protocol, and the URI is all of the things. And that's the best way of explaining that. So our URL, it includes HTTP, so the protocol, or in the case here, it's got secure FTP is the protocol, and then it's got example.com. And so there are different parts to the URI, and we're going to break that down. And that's basically what we're looking at. So the anatomy of a RESTful request is basically a query on top of your URI. So we've got our API server. So in a RESTful web service, the request is made to the resource's URI with an explicit response. The response is going to be a payload, typically formatted in JSON, but it could be HTML or XML or some other format. And so here we're showing, excuse me, a URI for MapQuest, which I didn't even know MapQuest still existed. Did you? Anyway, so it's MapQuest Directions API. So we've got our API server, which is the mapquestapi.com. And then we have our resources, which is direction version 2 root. And then we have the query, which is going to be the format and the key. The key is, and our parameters would be San Jose, from San Jose to Monterey. So it's basically simply a request for the directions from San Jose to Monterey. And you can do this in your browser, which is kind of cool. So you can play with some of these things. We've got the different parts of the API request. The API server, of course, is the URL for the server that answers the REST request. And the resources is exactly specifying the API that's being requested. So it's the directions API. The query specifies the data format and the information the client is requesting from the service. So the queries can include the format, which is usually JSON, but it could be YAML or XML. Here we're showing JSON format. And the key is the key for authorization. If required, MapQuest may require a key for its directions. So here you would have to replace key with a valid key to submit the valid request. And once again, you can receive that key from the API source. So the anatomy. First we're authenticating, and to authenticate, they're doing that specifically with a key so that they can limit the number of people and the number of requests. And then they can also capture and track the data. The MapQuest API does require a key. You can search the internet for a URL to get a MapQuest key. You can also, there's lots of API keys available out there for different resources. So you would use the search parameters developer.mapquest. You could also search the internet for the current URL that outlines the MapQuest privacy policy, as I said. Really, MapQuest? So our RESTful API applications. So developers' websites can contain API information. Postman is an all-inclusive application for using APIs. And you can call APIs from within Python, or you can use the netconf protocol. And some of our configuration management tools. So there's a good video there on some of the more modern management tools. Traditionally, we've managed our network devices using the CLI, right? And whenever there was a change or a new feature, we would have to enter the necessary commands manually into whichever appropriate devices. And that is really a major issue when we've got more complex configurations on larger networks. For our traditional network configuration, we would also use SNMP to manage our nodes on our IP network. And with Network Management Station, network administrators can use SNMP to monitor and manage our network performance, find and solve network problems, and perform queries for statistics. But we already know that SNMP has had security problems through the use of their community string, right? So we really shouldn't be using that for configuration due to those security concerns. And also, it's kind of a pain to implement. So we've kind of outgrown our traditional network configuration tools. And with that, we get to move on to our next generation of network automation tools. So we're moving away from a world where a network administrator has to manage just a few dozen network devices to one where we're deploying and managing a lot of devices, both physical and virtual. And we're doing that with the help of software. So this transformation is quickly spreading to all the places in the network. Network automation is really the only reasonable way to manage these complex networks. Because when you think about it, the more things we're connecting, the more things we need to manage. So configuration management tools usually include automation and orchestration. Automation is, of course, when the tool automatically performs a task on a system. Or orchestration is arranging those automated tasks, resulting in a coordinated process or workflow, which is really, that's a nice happy script that is accomplishing a number of different tasks. Some of the tools that are available, we've got Ansible, Chef, Puppet, and SaltStack. The goal of all of these tools is to reduce the complexity and the time involved in configuring and maintaining our large-scale network infrastructure. When we've got hundreds or even thousands of devices, that's something that we definitely want to consider. And these same tools can also benefit small networks as well. And if you have these tools in place in your small network, it makes it much easier when you are adding cloud resources to your network and software-defined networking. So when we're integrating our virtual resources, if we already have these in place and are comfortable with them, it does make that process much easier. So Ansible, Chef, Puppet, and SaltStack all come with API documentation for configuring RESTful API requests. All of them support JSON and YAML, as well as some other data formats. And here's a comparison of the major characteristics of Ansible, Chef, Puppet, and SaltStack. And all of these tools will help you automate tasks. You can choose the tool by the programming language that you're most comfortable with, or what's going to interface with your network best. IBN and Cisco DNA Center. So IBN is intent-based networking, and our Cisco DNA Center is the Cisco Digital Network Architecture Center. And so here we have a bit of a Cisco commercial. But it's also a good explanation on how to work with their software and manage and explore the Cisco DNA Center. So there's a good video on there. Intent-based networking, we're basically using a software-centric approach. And with that, IBM takes the network objectives and applies that to the intent for our network policy scripting. So we're trying to make sure that everything, that our most critical things have lots of redundancy and lots of ways of staying always on. Shouldn't use that term. So more of our intent-based networking. So we've got a couple of different things. There are 3 essential functions. We've got translation. And the translation function enables the network administrator to express the expected networking behavior that will best support whatever the business intent is. So we have to look at the business model in order to determine how we're going to do this. Activation of the captured intent then needs to interpret these policies and then apply it across the network. So the activation function basically installs these policies onto the physical and virtual networking infrastructure using network-wide automation tools. And assurance, so making sure that we're continually checking that the expressed intent is honored by the network and at any point in time. So assurance function is maintaining a continuous validation and verification loop to make sure that everything's running smoothly. So you'll be forewarned when there's a problem, which is really quite nice. A fabric. So the network fabric is the seamless integration of the physical network and the virtual network, making up the logical topology of your environment. We have the fabric, the overlay, and the underlay. So the fabric, of course, is the integration of the physical and virtual. We've got encapsulation protocols like IP security and control, and provisioning of wireless access points, and those occur at the overlay control frame. And all of the physical topology is in the underlay. And we talk about IP security and CCAP-WAP, which CCAP-WAP is control and provisioning of wireless access points. So that's the protocol that enables you an access controller to manage a collection of wireless termination points. It's defined in RFC 5415. If any of you are insomniacs and want some good reading material for 3 o'clock in the morning, read your RFCs. So here we've got an example of the underlay control plane. The underlay control plane is responsible for our simple forwarding tasks. The underlay network is the physical topology, including all of the hardware necessary to meet whatever business objectives that we have. The underlay reveals additional devices and specifies how these devices are connected. Our endpoints, such as the servers in this figure, access the network through the layer 2 devices. And data from the devices and the applications is continually gathered through Cisco DNA to provide an overall contextual view of the network information. And then the information can be analyzed to make sure that the network is performing securely at its optimal level and in accordance with the business intent and the network policies. So that's where we've got that constant analysis of what is actually going on in real time. Some of the things that make up the Cisco digital network architecture, we've got our SD access, and that was the first intent-based enterprise networking solution built into using Cisco DNA. We've got SD-WAN, which you hear a lot of, and that's your cloud delivered architecture. And how are we going to integrate that in with our local resources? We've got DNA assurance, which is keeping on track of everything. So it's used to troubleshoot and increase the IT productivity. It's going to use advanced analytics and machine learning to make sure that we're working at optimum performance, and that if there's any issues that need resolving, also to predict any network performance problems. And then we've got Cisco DNA security, and that provides visibility using the network as a sensor for real-time analysis and intelligence. So we've got a little more granular control over enforcing policy and threats. So the DNA Center is a foundational management and command center platform. The interface launch page gives you a dashboard showing an overall health summary and a network snapshot. So from here, the network administrator can quickly drill down into areas that they're interested in. So we've got a single pane of glass dashboard that we can look at our entire network and everything that's going on in real time, which you don't have from the CLI. I mean, the best you can do is what gather statistics and show CDP neighbors detail, right? From the CLI, you don't have nearly as a great an overview as you do from the Cisco DNA Center. There's a number of different options at the top on the menus. We've got design, which is where you model your entire network, from sites and buildings to devices and links, both physical and virtual, across your campus, branch, WAN, and cloud. Policy, you use policies to automate and specify network management, and so that reduces the costs and risks while speeding the rollout of new and enhanced services. Provision, so providing new services to users with ease, speed, and security across your enterprise network, regardless of the network size or complexity. Assurance, of course, using proactive monitoring and insights from the network devices and applications to predict problems faster and ensure that policy and configuration changes achieve the business intent and the user experience that you want. So maybe some of those things should be used for the loans that are available through for small businesses right now. And then, of course, we have the platform. So we use APIs to integrate with your preferred IT systems, and then you can create end-to-end solutions to support and add support for multi-vendor devices. So with these APIs, especially the open APIs, we can manage and view all of our network hardware, and we can do that regardless of what vendor has created it. So that's really pretty cool. There's a good video of the Cisco DNA Center GUI, and it includes all of those different menu items that you can look at. There's another great video on design and provision. And also, when you have one of these dashboards, it can also send out crawlers to explore and find new devices that were connected. So in the instance of a user that maybe has added a wireless access point in their office that nobody knows about, we would be able to find that wireless access point through our crawlers, through our network crawlers. The DNA Center and Policy Assurance basically is just trying to make sure that everything is, it allows you to quickly troubleshoot and view all of your network devices. So it seems a little more complicated. There's a lot more layers. So it's a little bit more complicated than just working with a CLI. But it certainly does aid your processes. And so there's another video on troubleshooting user connectivity. Please, if you haven't already watched those videos, please make sure that you watch those videos, because they are really good. They're not just commercials on how great Cisco DNA is, but it's also showing you a walkthrough step by step of all the different ways that it can integrate. And then once you've watched those videos, if you do that along with going into the Cisco DevNet environment and playing in some of those sandboxes, you can really hone those skills required to master, this integration process. So we talked about automation, of course, and that's any process that's self-driven, and it eliminates the need for human intervention, which also makes it not human error. So there's another good thought, is that if there is a problem with the code that you didn't write, and it, then it's really not your fault if something doesn't work the way you expected it to. Of course, you're going to be writing the code, so never mind. We've got our smart devices, and in order for them to think, they need input data from other things to use. It's kind of, I want to say it's kind of like piping. When you're programming and you're using a pipe, you're taking the output of one application, right? And then you're piping it into another command. So you can kind of look at it that way. We've got some common data formats like JSON, XML, and YAML. APIs, of course, are a set of rules describing how one application can interact with another and manage and facilitate those interactions. We've got different types of APIs. We've got open, public, internal, and private. We've got 4 different types of web service APIs. We've got SOAP, which has been around forever. That's Microsoft-based. REST, XML, RPC, and JavaScript or JSON. So REST API, of course, has functions that developers can use using the HTTP protocol. And when something conforms to the constraints of REST, then it's RESTful. And as I said, RESTful APIs use HTTP methods. And when you're using, so if you're running Wireshark and you're accessing a web page, you're going to see the access of that web page. You're going to see the post in the Wireshark PCAP file. So let's see. We need to be familiar with a URI. The URI is going to have the URL and the URN. So it's going to have not only the website and the server, but also the resource inside of that. We've got different parts of the REST API. We've got the server, the resources, and the query. Of course, the query is going to include what format we're going to have, the key, and what parameters. We've got configuration management tools to automate tasks, and those are, you know, Chef and Puppet and Ansible. Ansible. There's no T. I always want to put a T there. Sorry. And Cisco views IBN as having 3 essential functions, basically translation, activation, and insurance. And the DNA Center is a dashboard where you can, you know, it's an overreaching view of your entire network where you can see everything interacting with each other in a nice little dashboard manner.